Hello everyone. Welcome to the next video on welding transformer. Myself Ganesh from Kekewag Institute of Engineering Education and Research, Nashik. The content of today's session are the requirements of welding transformer, construction of welding transformer, types of welding transformer. In that, we are going to see the high reactance type welding transformer, external reactor type welding transformer, integral reactor type welding transformer, and saturable reactor type welding transformer. The learning outcome of today's session are, at the end of this session, learner will be able to recognize the importance of welding transformer, elaborate the construction of welding transformer, classify the welding transformer based on the construction, draw the connection diagram, and characteristics of different types of welding transformer. The requirements of welding transformer. So before going to the construction of welding transformer, what are the requirements of welding transformer that we'll explore first? So welding transformer should work on the three-phase or single-phase distribution voltage, because the welding transformer is going to work on the distribution side. So it must work on the distribution voltage. In India, for a single phase we have 230 volt, and for a three-phase we have 440 volt. So primary of the welding transformer must be work on 230 volt or 440 volt depending upon the number of phases available. The open circuit output voltage of the welding transformer is generally lies between 50 to 80 volt. It should not exceed the 100 volt in any case. The 50 to 80 volt is sufficient to initiate the arc. If we keep the voltage on higher side, it is not economical for the welding, because the welding material will be get wasted in that case. So open circuited output voltage must be lies between 50 to 80 volt. Then we require a controllable continuous output current. So output is nothing but a secondary current. The secondary current rating is lies between 50 ampere to 1000 ampere. So we can see here, this is the tip of your welding rod, and here you are going to weld. So while doing the welding, this metal should be melt and it should be deposited here. So this metal cannot be melted without heat. So heat which is generated here is nothing but the I square R T. So T is the time. The time which is required to weld is must be very less. The resistance of this rod is fixed. So the current, so to get the high output, you require a very high amount of current. Hence, the continuous current of 50 to 100 ampere. Why we require a continuous current? Because if the continuous current only can melt this, and the welding will be uniform over the surface. Otherwise, the welding will not be uniform over the surface. It should have a dropping VI characteristics. So dropping VI characteristics means open circuit voltage is high for a low value of the current. So current is taken on this axis, voltage is taken on this axis. So this characteristics is dropping in nature. So voltage will be less for high amount of the current. The secondary current is large. So you will observe that the secondary current is large, hence the number of turns on the secondary must be less. So by the ratio, we know that the V1 by V2 is equal to N1 by N2 is equal to I2 by I1. As we require this I2 amount of the current is very high, so we have to keep this N1 N2 number of turns on the secondary side must be less. So these are the requirements of welding transformer. So from this we will form a construction of welding transformer. So the next slide is about the welding transformer construction. So in this welding transformer, you observe here the welding transformer have a large number of turns on the primary and less number of turns on the secondary. Similarly, you will observe here this is a shell type of transformer, large number of turns on the primary and less number of turns on the secondary side. On the secondary side, we have connected the electrode and piece to be welded. The thick size of conductor on secondary side. So here the conductor size on the secondary must be very thick. We require a thick size of conductor over here? Because it must be able to handle 50 to 1000 ampere of the current. So to handle this much amount of current, the secondary winding must be capable. Hence, the thickness of the secondary winding is larger, as the current rating of the conductor is proportional to the thickness of the wire. The primary of the secondary winding have high reactance, that is a high leakage flux. So secondary and primary winding is having the high reactance, that is a high leakage flux. Primary or secondary or core. So to control the output current. So if you want to control the output current, either you have to move the primary, either you have to move the secondary or number of turns, or you have to move the core. So there are three options: by moving the core, by moving the primary winding, by moving the secondary winding, or changing the number of tappings on the secondary, we can change the output current. So depending upon this, the construction of the types of the welding transformer are high reactance type welding transformer, external reactor type welding transformer, integral reactor type welding transformer, saturable reactor type welding transformer. So again, this high reactance type of welding transformer have three types. In the first one, prime moving coil is there, so coil is moved in this case. In the second one, there are tappings on secondary, and in the last one the core is moved. So we are going to see that these three main types in the high reactance type, and others are external, integral, and saturated reactor type. So uh, we'll see the high reactance welding type transformer. In that moving coil high reactance type welding transformer, here you can observe that the primary winding is here and the secondary winding is here, and it is mounted on mounted on a screw. So by varying this screw, the distance between the primary winding and secondary winding can be changed. So if the distance between the primary winding and secondary winding is larger, then it offers a large reactance. It offers the large reactance and less current output. So this, as the gap is in between this is large, so it offers the large reactance. So as XL value is greater, obviously the current value is going to decrease. Hence, the less current you will get, and you will get the fast drooping characteristics over here. So when the distance between these two is large, you will get the minimum output. If the distance between primary and secondary winding, here you can see the distance between primary and secondary winding is less. So as the distance is less, it offers the less reactance. As the value of XL is less, it can provide the high amount of output current, that is the I2 current. So I2 current will be larger, so you will get the maximum output, and it is a slow drooping characteristics you will observe over here. VA characteristics you will observe here. In the next type of the transformer, this is the high reactance type transformer. In this, secondary is tapped, so you can see there are the tappings on the secondary. So the value of the inductance is equal to n square upon s. Here the reluctance is fixed, so I'm going to vary. As I want to vary the secondary current, I will vary the secondary number of turns, that is n2 number of turns. When it is at this position, the n2 value is large. As the n2 value is large, your inductance value is large, hence XL is large, so you will get the less amount of the current. So in this case, high tapping, large number of turns on the secondary, large reactance, and less current output. If we keep, so sorry, is not high tapping, low tapping. If the tapping is on this side, so now let us consider that this is connected over here. So N2 is reduced, as number of turns on the secondary is reduced, inductance is reduced, XL is reduced, hence the current in the secondary winding is large, hence you will get a slow drooping VI characteristics. In the next type, movable magnetic shunt type reactance. So here, the primary and secondary winding is fixed. The number of turns are fixed, and this is not movable. But the central core is movable. So the flux produced by the primary have a two path. One is going through this shunt magnet and another is going to this magnet. So let us consider the reluctance of this path is S1 and reluctance of this path is S2. So net reluctance is equal to S1 parallel with S2. That is, net reluctance is equal to S1 S2 upon S1 plus S2. So if we change the core position, let's see what will happen. So if we move the core this inside, if you move the core this inside, this air gap is reduced. As air gap is reduced, the value of S1 is going to reduce. As the value of the S1 is going to reduce, so your inductance is equal to N square upon S. S is going to reduce, so it will give the large inductance. So large inductance means XL increases and current decreases. So you will observe the less output current at this side. When you move the when movable core is less inside, that is, I'm moving this core to this outside, it will create a large air gap. Due to the large air gap, the reluctance value is goes on increasing. The reluctance value is goes on increases, you will get a less reactance, hence large output current. So that slow drooping VI characteristics you will get. So for more core inside, you will get this characteristics A, and for more core outside, you will get this characteristics B. The next type is the external reactor type of the core. In this external reactor type of welding transformer, in this you can see the transformer is having the fixed number of primary turns, fixed number of secondary turns, and there is no moving core. But here you will observe that the external reactor is connected in series with the secondary, and one of the arm of this external reactor is keep moving. So if this is at the position number 1, when this is at the position number 1, it offers the large reactance. So when it is at the position number 1, its gap is less, hence L is equal to N square upon S. As the air gap is less, the value of S is small, hence the value of L goes on increasing. As the L goes on increasing, XL is also grows on increasing and the current decreases. So at the position number 1, you will get this type of the characteristics, that you will get the less output of the current. When you move this moving core in upward direction, that is at the position number 2, at the position number 2, the value as the air gap is more, the value of S is more, that is reluctance is more, hence the value of the inductance is more, so value of XL is more, hence sorry, as the L as the value of the reactance is more, the value of the inductance is low, value of the XL is low, hence the current value is high, hence you will get these characteristics too. So you will get the large output current in that case. So moving core near to the external reactor, large reactance, less output current, fast dropping VI characteristics. Moving core away from the external reactance, less reactance, high current output, and slow dropping VI characteristics. The next type is the integral type of integral reactor type of welding transformer. In this integral reactor type of the welding transformer, there is one winding on the primary and secondary winding is split up into two parts. That is, this is the second one and the third one. So if I draw this third winding separately and the second winding separately, if you connect this terminal like this and if you are taking the output from this, let the voltage induced here is the E2, voltage induced here is the ER, then the net output voltage where you are getting hit here is ET is equal to ER upon E2. Whereas in this case, these two windings are connected, the winding 3 and winding 2 are connected such that they will produce the output ET. Okay, so they will produce the output ET is equal to E2 minus ER. That is, it is in series opposition, or it is differential output and it is the additional output. So, and in both constructions, there is a moving core. So if we moving core is near to the main core, then it will offer a large reactance, as we seen in the previous case, less output current and fast dropping VI characteristics. If this moving core is away from the main core, less reactance, high output of the current, hence slow dropping VI characteristics. For a low output current, we can connect the winding 3 and 2 for in series adding position, whereas to get the high output of the current, we can connect this two winding in the series opposition mode. So by this way, we will get the characteristics A for characteristics A and characteristics B respectively. Then next type of the welding transformer is a saturable reactor type welding transformer. In the saturable reactor type of welding transformer, it is the AC/DC type of the welding transformer. You can see this main transformer will convert, will have a AC supply, and on the secondary side, we connected one reactor. The central limb of this reactor is supplied by the DC supply. Here, the AC supply is converted into DC supply by the use of this rectifier, and this resistance is control the current flowing through this central winding. As the current flowing through the central winding is controlled, that is the very low voltage and low ampere DC current which is injected over here, but it can capable to control the output AC current which is gained by this electrode. So effective magnetic field characteristics can be controlled by using the small amount of DC current. That is, a large amount of AC current can be controlled by relatively small amount of DC current. Hence, it is made to possible the output changes from minimum to maximum. Less the DC current flowing, minimum impedance, maximum output. More the DC current flowing in the reactor coil, more impedance, minimum output at the minimum output of the saturable reactor type of welding transformer. So all this information I have collected from these websites. You can visit to this website. With this, we are at the end of presentation. Thank you. Please subscribe my channel and leave your comment in the comment box. Thank you.